Okay, everyone, we're going to look at number 6 in section 3.6. We're going to find the derivative capital R prime of y. So capital R is the function of the independent variable y. If R of y is 7 cosine y minus 8 divided by sine of y. Again, your function that you're given might have slightly different numbers, but should look similar to this. Okay, I'm going to show you how to do this in two different ways. First way, I'm going to just straight up use the quotient rule. Okay, we got one function divided by another, so you could always try the quotient rule when something like that. So let's do that. Let's take the quotient rule. Remember the quotient rule. If you have u divided by v and you take the derivative, u is the top function, v is the bottom function. Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom function squared. Okay, so you'll need to remember the quotient rule. Very important that you remember how that works. And the order you subtract here does matter. So, talk about ways to remember the quotient rule, how you can check yourself in my lecture videos. So I would encourage you to do that. Okay, so the top function is 7 cosine y minus 8. So we take the derivative of the top function here times the bottom minus the bottom, times the bottom minus the top times the derivative of the bottom. Sorry, I had that backwards. Over the bottom function squared, right? V being sine of y, sine squared y. So what's the derivative of 7 cosine y minus 8? Well, the derivative of 7 cosine y is negative 7 sine y, right? The derivative of cosine y is negative sine y. 7 is a constant multiple, so I multiply by -1, I get negative 7 sine y. Derivative of 8 is just 0. So I just get that. And the derivative of sine of y is cosine of y. Okay. Now, cleaning this up, I got negative 7 sine y times sine y. That's negative 7 sine squared y. And then I've got negative 7 cosine y times this cosine y is negative 7 cosine squared y. And then notice here, negative times negative is positive 8 times the cosine y. Notice the cosine y gets distributed through this just like the negative sign does. So I get plus 8 cosine y. Now, all over the sine squared y. So this is the derivative, but when I've circled this because there should be something here that kind of catches your eye in here. Is there something we can do to simplify right here? I hope you see it. Notice both of these have a common factor of -7. And when I factor that -7 out, what am I left with? Sine squared y plus cosine squared y. You should immediately recognize that as the Pythagorean identity. That's the most fundamental identity we have in trigonometry. Sine squared y plus cosine squared y equals 1. That comes directly from the unit circle. We think about the equation of the unit circle. We see exactly where that comes from. And so that's what you want to do. You want to simplify that right down to just 1. And so I get -7. Don't forget, we still have this plus 8 cosine y up here, all divided by sine squared y. Or you could rewrite this. A -7 plus 8 cosine y is the same as 8 cosine y plus a -7 or 8 cosine y minus 7. So either one of these would be acceptable, I think. Okay, I'm just going to show you real quick another way to find the derivative. You don't have to use the quotient rule in this problem. You can notice divide. You got a numerator 7 cosine y minus 8. You can divide the numerator by this denominator, distribute that right through, right? Dividing by sine of y on both of those, right? I can break it up into 2 separate fractions. And then I can rewrite cosine y over sine of y as cotangent y. And 1 over sine of y is cosecant y. So I get 7 cotangent y, 8 cosecant y. And now I can find the derivative, but I do have to know the derivative of cotangent is negative cosecant squared y, right? And the derivative of cotangent y is negative cosecant squared y. And I've got -8 constant multiple. Derivative of cosecant y is negative cosecant y cotangent y. So again, those are derivatives you should know. And then I can clean this up. A negative times a negative makes this positive 8 cosecant y cotangent y minus 7 cosecant squared y. Just change the order of these two. Okay. And that could be your derivative right there. And you say, well, wait a minute, let's compare it to what we had here, right? These do not look the same. How are these the same derivative? Well, we can get this one over here on the right to look like what we got the first time. So the derivative was easy to find, but to make it look like this, we've got to do a little bit of work, which is basically to go back to sines and cosines, right? Cosecant y is 1 over sine y, cotangent y is cosine y over sine y, cosecant squared y is 1 divided by sine squared y. So notice this expression here, 8 cosecant y cotangent y can be rewritten as 8 cosine y sine squared y, and then 7 cosecant squared y is just 7 over sine squared y. Notice these have a common denominator of sine squared y, so I can just subtract them. And if you look now, look at there, we've got the same thing. Okay. So there's multiple ways sometimes with, especially with the trig functions, we can rewrite the function in a different way, find the derivative, in this case, without the quotient rule. Okay, so some neat stuff there with derivatives of trig functions. Hope this is helpful.